Hey guys, it's time for chapter 9.2 in our trig adventure here. So today we're going to talk about two things. First, we're going to talk about drawing angles in standard position. So here we have an XY axis and we have a circle, right, where the origin is the center. I know my drawing is not very good, but the origin of the XY axis is at the center of the circle. So if we think of a circle, we know if a circle has 360 degrees. So if we start right here at the positive x-axis and we head up here, we now have covered a fourth of the circle. So this is 90 degrees up here. We continue on our journey. Now we're halfway around the circle. That's 180 degrees. Now we're 3/4 of the way around the circle. And then now we're back to the circle beginning. So that's what we've got. And we can draw an angle, any angle on this circle. So a little bit of vocabulary. The vertex of our angle is going to be at the origin, as we spoke, the center of the circle. The initial side, which is the beginning, kind of the starting point of the angle, is always going to lie on the x-axis, like this. Now, just to make things a little more complicated, you can actually have a positive angle or a negative angle. If I'm going to have a positive angle, it's going to go up. So starting at the positive x-axis, my positive angle is going to go up. If I have a negative angle, it's going to go down. Okay, suppose I want to go, I'm going to do a positive angle. Let's say I want to start at my initial side and I want to head around the circle, and let's say I'm going to end up right here. The ending side is called the terminal side. And what we have right here is an angle. So that's our vocabulary. So let's practice drawing some angles. Okay. So here's our first one right here. Sorry, my circles are not going to be really great, unfortunately. You guys know how good I am at art. Okay, so what if we want to draw a 240 degree angle? Okay, so we're going to start at our initial side, which is right here, right? And we remember this is 90, right? This is 180, and this is 270. So our 240 degree angle, the terminal side, is going to be somewhere here in quadrant 3. So let's say we've got a positive 240. We're going to go up and around, and we get to 180, right? And we want 240, so we're going to go another 60 degrees. Now this obviously is not perfect. I'm not using a protractor, but we're getting the general idea that that's 240 degrees. Okay. Look at the next one. The next one's a little bit tricky because what do you notice? If it's 500 degrees, that means that's more than 360, right? So if I have a 500 degree angle, sorry, I gotta keep adjusting this. If I want a 500 degree angle, I've got to go around the circle the entire way. I've got to make a whole 360 degree rotation around the circle. So let's start with our initial side right here. I'm going to go around the entire circle, and that's 360 right there, right? Now, how much is left after I've gone 360? Well, 500 minus 360 is 140 degrees, right? So I'm going to go an additional 140 degrees. So this is 90, that's 180. So 140 degrees will go an additional around there, right? Now again, it's not really precise, but it's pretty close, right? So that's to go another around the circle the entire time plus an additional 140. Now the last one here is a negative angle. So what if I want to go, notice on those, both on those positive angles, I went I started at my initial side and I went up. If I want a negative angle, maybe I'll do it this way. That's probably easier. If I want a negative angle, negative 50 degrees, well, I'm going to start the same way I always do, at the initial side, but instead of going up, I'm going to go down 50 degrees. Now, we know this is 90, so 50 is going to be a little more than halfway. So this we're going to call negative 50 degrees. So just to sum up, positive angle, you start at your initial side, go up. Negative angle, go down, and sometimes you have to go more than one time around the circle. Okay, so now we're going to talk about a new idea called coterminal angles. So if you noticed when we did 500 degrees, we had to go around the circle an entire time before we hit our 500 degrees. So coterminal angles have the same terminal side. Now, what does that mean exactly? That means that that angle ends up in the exact same place as another angle. So how could that be? How could I have two angles that end up at the exact same endpoint? Well, I can have that because I can draw an angle and then I can go a whole nother degree, whole nother circle around again and hit that same exact terminal side. So that's what we're going to do here. Let's sketch, for example 2, let's sketch the angle and give one positive and one negative coterminal angle. Okay, so let's look at A. They want us to sketch negative 45 degrees. So let's go like this. Right? We're going to sketch negative 45 degrees by going, okay, we're going to start at our initial side. It's a negative angle, so we're going to head down this way. This is at negative 45 degrees. Right? Now notice, I could also express this as a positive angle. Right? I could go around all the way around this way and express it as a positive angle. So the same angle can be expressed in multiple ways. So they want me to find one positive coterminal angle and one negative coterminal angle. Well, if I want a coterminal angle, look what I can do, guys. If I want a positive coterminal angle, I can go all the way around the circle and then get to that same terminal side. So to get a positive coterminal angle, I'm just going to take the angle and add 360 degrees. Right? Because what I'm doing here is I'm going around the circle. So I can say negative 45 plus 360. And that's going to give me a positive coterminal angle, which is 315 degrees. So I could take this and go all the way around and make it 315 degrees. How about a negative coterminal angle? Well, let's see. Positive coterminal angle, I could do a whole circle around this way. I could also go a negative way all around the circle and end up in that same spot. So I can find a negative coterminal angle by doing negative 45 degrees minus 360, right? Because I'm going the negative direction, which would give me negative 405 degrees. Hopefully that makes sense. Okay, let's look at part B. Sorry, I don't have my 6 boards. I really miss them. Okay, part B says 395 degrees. So first they want us to sketch 395 degrees. And then they want us to find a positive and a negative coterminal angle. Okay, so 395 degrees is more than an entire circle, right, guys? So how many more degrees is it than an entire circle? Well, an entire circle is 360, right? So 395 would be an extra 35 degrees. So watch what I'm going to do here. Here's my terminal side. I'm going to go around once, and then I'm going to go an extra 35 degrees. So we're going to call that 395. Okay, if they want me to find a positive coterminal angle, all I'm going to do is add 360 to this 395. So 395 degrees plus 360. And that is going to give me, oops, sorry. I didn't do, so 395 was 360. I didn't do that on my paper. 395 plus 360 is 755. Right? Or, yeah, we'll just stick with that. Positive coterminal angle, 395 plus 360. What about a negative coterminal angle? Well, what I'm first going to do is I'm going to subtract 360. So 395 minus 360 is 35. Are we at a negative angle yet? Not yet. So we have to subtract 360 again. And once we subtract 360, sometimes we have to do it more than once to get us into the negative land, the negative coterminal angle land. So I may have to subtract 360 more than once, or if the angle is negative, I may have to add 360 more than once. Okay, guys, that is what we're doing for coterminal angles. Next, and this is our last thing, if we think of a circle, guys, I'm going to draw it. We think of a circle as 360 degrees, right, guys? That's if we're measuring the angles in the circle, right? So if I am measuring any angle, degrees in a circle, I can think of a circle that way, right? But another way I can think of a circle is I can think of a circle as the distance around the outside of the circle. So like that, right? So I can measure a circle by its degrees, or I can measure a circle by its circumference, right? So here are degrees, but I could also measure circumference, which, if you remember from geometry, is 2 pi r. So what if I have a circle with a radius of 1? Well, that circle would have 360 degrees, and it would have a circumference of 2 pi times 1, which is 2 pi. So we can think of a circle as either a measure of its circumference or a measure of its degrees. Now, when we're thinking of a circle and a measure of its circumference, we're thinking of something called a radians. So one circle is equal to 2 pi radians, and it's also equal to 360 degrees. So I can think of the circle in either way. So what I want to do is be able to convert back and forth between the two ways of thinking of a circle. So I can think of a circle, if I have degrees, I can convert to radians. If I have radians, I can convert to degrees. So if I want to convert degrees to radians, what I'm going to do is this. I'm going to take the degree measure and I'm going to multiply it times pi over 180. Now, what if I have the radian measure? Well, if I have the radian measure, I'm going to do radian measure times 180 over pi. Now, this may be blah, 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 blah. This seems really kind of hard to sink your teeth into until we do an example. So let's do our last bit here. Grand finale is example 3. So we want to convert the degrees to radians and the radians to degrees. Right? So whatever ones are in Degrees we're going to make radians, and any of them in radians we're going to make degrees. So let's see. A is 120 degrees. So if I look back, I know that I'm going to take my degree measure, do 120 times pi over 180. Okay, guys, so what I can do is I can reduce this. I think I can finish in 2 minutes. I can reduce this, right? I can say, okay, well, that's 12 pi over 18, which can be reduced even more to 2 pi over 3. Okay, second one. What if I have negative 80 degrees? Well, I'm going to take negative 80 times pi over 180. And again, I can reduce negative 8 pi over 18, which can be reduced again to negative 4 pi over 9. Okay, how about this, guys? 5 pi over 4. Well, that's radians, so I'm going to multiply it by 180 over pi. And watch what happens, guys. The pi's go out. So I have 5 times 180 over 4, which is 225 degrees. And our last one, negative pi over 12. Well, I'll take negative pi over 12 times 180 over pi. And again, the pi's cancel. And I get negative 180 over 12, which is negative 15 degrees. All right, guys, that's chapter 9.2. See you for 9.3.